So far, I have read the first 20 pages of the book The Beginning of the Infinity, written by David Deutsch. Today, I'm going to read from the pages 21 to 30. So the next 10 pages. So the page 21 starts like this. The Persephone and Freyr meet assert radically incompatible things about what is happening in reality to cause seasons. Yet no one, I guess, has ever adopted either meat as a result of comparing it on its merits with the other. Because there is no way of distinguishing between them, if we ignore all the parts of both myths whose rule could be easily replaced, we are left with the same core explanation in both cases. The gods did it. Although Freyr is a very different god of spring from Persephone, and his battles very different events from her conjugal visits, none of those differing attributes has any function in the myths, respective accounts of why seasons happen. Hence, none of them provides any reason for choosing one explanation over the other. The reason those myths are so easily variable is that their details are barely connected to the details of the phenomena. Nothing in the problem of why winter happens is addressed by postulating specifically a marriage contact or a magic seed, or the gods Persephone, Hades, and Demeter or Freyr, whenever a wide range of variant theories can account equally well for the phenomenon they are trying to explain. There is no reason to prefer one of them over the other, so advocating a particular one in preference to the others is irrational. That freedom to make drastic changes in those mythical explanations of seasons is the fundamental flaw in them. It is the reason that myth making in general is not an effective way to understand the world, and that is whether the myths are testable or not. Whenever it is easy to vary an explanation without changing its predictions, one could just as easily vary it to make different predictions if they were needed. For example, if the ancient Greeks had discovered that the seasons in the northern and southern hemispheres are out of phase, they would have had a choice of countless slight variants of the meat that would be consistent with that observation. One would be that when Demeter is sad, she banishes warmth from her vicinity, and it has to go elsewhere into the southern hemisphere. Similarly, slight variants of the Persephone explanation could account just as well for seasons that were marked by green rainbows, or seasons that happened once a week, or sporadically, or not at all. Likewise, for the superstitious gambler or the end of the world prophet, when their theory is refuted by experience, they do indeed switch to a new one, but because their underlying explanations are bad, they can easily accommodate the new experience without changing the substance of the explanation. Without a good explanatory theory, they can simply reinterpret the omens, pick a new date, and make essentially the same prediction. In such cases, testing one's theory and abandoning it when it is refuted constitutes no progress towards understanding the world. If an explanation could easily explain anything in the given field, then it actually explains nothing. In general, when theories are easily variable in the sense I have described, experimental testing is almost useless for correcting their errors. I call such theories bad explanations. Being proved wrong by experiment and changing the theories to other bad explanations does not get their holders one jot closer to the truth. Because explanation plays this central role in science, and because testability is of little use in the case of bad explanations, I myself prefer to call myths, superstitions, and similar theories unscientific even when they make testable predictions. But it does not matter what terminology you use so long as it does not lead you to conclude that there is something worthwhile about the Persephone myth or the prophet's apocalyptic theory or the gambler's delusion. Just because it is testable, nor is a person capable of making progress merely by virtue of being willing to drop a theory when it is refuted. One must also be seeking a better explanation of the relevant phenomena. That is the scientific frame of mind. As the physicist Richard Feynman said, science is what we have learned about how to keep from fooling ourselves. This is fantastic. I am going to read it again. Science is what we have learned about how to keep from fooling ourselves. By adopting easily variable explanations, the gambler and prophet are ensuring that they will be able to continue fooling themselves no matter what happens, just as thoroughly, or if they had adopted untestable theories, they are insulating themselves from facing evidence that they are mistaken about what is really there in the physical world. The quest for good explanations is, I believe, the basic regulating principle not only of science but of the Enlightenment generally. It is the feature that distinguishes those approaches to knowledge from all others, and it implies all those other conditions for scientific progress I have discussed. It trivially implies that prediction alone is insufficient. Somewhat less trivially, it leads to the rejection of authority, because if we adopt a theory on authority, that means that we would also have accepted a range of different theories on authority, and hence it also implies the need for a tradition of criticism. It also implies a methodological rule, a criterion for reality, namely that we should conclude that a particular thing is real if and only if it figures in our best explanation of something. Although the pioneers of the Enlightenment and of the scientific revolution did not put it this way, seeking good explanation was and remains the spirit of the age. Spirit of the age. This is how they began to think. It is what they began to do systematically for the first time. It is what made that momentous difference to the rate of progress of all kinds. Long before the Enlightenment, there were individuals who sought good explanations. Indeed, my discussion here suggests that all progress, then as now, was due to such people. But in most ages, they lacked contact with a tradition of criticism in which others could carry on their ideas, and so created little that left any trace for us to detect. We do know of sporadic traditions of good explanation seeking in narrowly defined fields, such as geometry, and even short-lived traditions of criticism, mini enlightenments, which were tragically snuffed out, as I shall describe in chapter 9. But the sea change in the values and patterns of thinking of a whole community of thinkers, which brought about a sustained and accelerating creation of knowledge. happened only once in history with the Enlightenment and its scientific revolution. An entire political, moral, economic, and intellectual culture, roughly what is now called the West, grew around the values entailed by the quest for good explanations, such as tolerance or dissent, openness to change, distrust of dogmatism and authority, and the aspiration to progress both by individuals and for the culture as a whole. And the progress made by that multifaceted culture in turn promoted those values, though, as I shall explain in chapter 15, they are nowhere close to being fully implemented. Now consider the true explanation of seasons. It is that the Earth's axis of rotation is titled relative to the plane of its orbit around the Sun. Hence, for half of each year, the northern hemisphere is tilted towards the Sun, while the southern hemisphere is tilted away, and for the other half, it is the other way around. Whenever the Sun's rays are falling vertically in one hemisphere, thus providing more heat per unit area of the surface, they are falling obliquely in the other, thus providing less. The true explanation of seasons, not to scale. So here's a picture shown. That is a good explanation, hard to vary because all its details play a functional role. So what I can learn from is that good explanation does not vary, or it is hard to vary. For instance, we know and can test independently of our experience of seasons that surfaces tilted away from radiant of our experience, radiant heat are heated less than when they are facing it, and that a spinning sphere in space points in a constant direction. And we can explain why in terms of theories of geometry, heat, and mechanics. Also, the same tilt appears in our explanation of where the Sun appears relative to the horizon at different times of year. In the Persephone myth, in contrast, the coldness of the world is caused by Demeter's sadness, but people do not generally cool their surroundings when they are sad. And we have no way of knowing that Demeter is sad or that she ever cools the world, other than the onset of winter itself. One could not substitute the moon for the sun in the axis tilt story, because the position of the moon in the sky does not repeat itself once a year, and because the sun's rays hitting the earth are integral to the explanation. Nor could one easily incorporate any stories about how the sun god feels about all this. Because if the true explanation of winter is in the geometry of the earth-sun motion, then how anyone feels about it is irrelevant. How anyone feels about it is irrelevant. And if there were some flaw in that explanation, then no story about how anyone felt would put it right. The existential theory also predicts that the seasons will be out of phase in the two hemispheres. So if they had been found to be in phase, the theory would have been refuted, just as in the event, the Persephone and Freyr myths were refuted by the opposite observation. But the difference is, if the existential theory had been refuted, its defenders would have had nowhere to go. No easily implemented change could make tilted axes cause the same seasons all over the planet. Fundamentally new ideas would have been needed. That is what makes good explanations essential to science. It is only when a theory is a good explanation, hard to vary, that it even matters whether it is testable. Bad explanations are equally useless whether they are testable or not. Most accounts of the differences between myth and science make too much of the issue of testability, as if the ancient Greeks' great mistake was that they did not send expeditions to the southern hemisphere to observe the seasons. But in fact, they could never have guessed that such an expedition might provide evidence about seasons unless they had already guessed that seasons would be out of phase in the two hemispheres. And if that guess was hard to bury, which it could have been only if it had been part of a good explanation. If their guess was easy to bury, they might just as well have saved themselves the boat fare, stayed at home, and tested the easily testable theory that winter can be staved off by yodeling. Yodeling. So long as they had no better explanation than the Persephone myth, there should have been no need for testing. Had they been seeking good explanations, they would immediately have tried to improve upon the myth without testing it. Again, so long as they had no better explanation than the Persephone myth, there should have been no need for testing. Had they been seeking good explanations, they would immediately have tried to improve upon the myth without testing it. That is what we do today. We do not test every testable theory, but only the few that we find are good explanations. Science would be impossible if it were not for the fact that the overwhelming majority of false theories can be rejected out of hand without any experiment, simply for being bad explanations. Good explanations are often strikingly simple and elegant. As I shall discuss in chapter 14, also a common way in which an explanation can be bad is by containing superfluous features or arbitrariness, and sometimes removing those yields a good explanation. Removing those yields a good explanation. This has given rise to a misconception known as Occam's razor, named after the 14th century philosopher William of Ockham, but dating back to antiquity, namely that only should always seek the simplest explanation. One statement of it is, do not multiply assumptions beyond necessity. However, there are plenty of very simple explanations that are nevertheless easily variable, such as Demeter did it. And while assumptions beyond necessity make a theory bad by definition, there have been many mistaken ideas of what is necessary in a theory. Instrumentalism, for instance, considers explanation itself necessary, and so do many other bad philosophies of science, as I shall discuss in chapter 12. When formally a good explanation has been falsified by new observations, it is no longer a good explanation. Right. I'm reading it again. When a formally good explanation has been falsified by new observations, it is no longer a good explanation because the problem has expanded to include those observations. Thus, the standard scientific methodology of dropping theories when refuted by experiment is implied by the requirement for good explanations. The best explanations are the ones that are most constrained by existing knowledge, including other good explanations as well as other knowledge of the phenomena to be explained. That is why testable explanations that have passed stringent tests become extremely good explanations, which is in turn why the maximum testability promotes the growth of knowledge in science. Conjectures are the products of creative imagination. But the problem with imagination is that it can create fiction much more easily than truth. 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 As I have suggested, historically, virtually all human attempts to explain experience in terms of a wider reality have indeed been fiction in the form of myths, dogma, and mistaken common sense. And the rule of testability is an insufficient check on such mistakes. But the quest for good explanation does the job. Inventing falsehoods is easy, and therefore they are easy to bury once found. Discovering good explanations is hard, but the harder they are to find, the harder they are to bury once found. The ideal that explanatory science strives for is nicely described by the quotation from Wheeler with which I began this chapter. Behind it all is surely an idea so simple, so beautiful, that when we grasp it in a decade, a century, or a millennium, we will all say to each other, how could it have been otherwise? My italics. Now we shall see how this explanation-based conception of science answers the question that I asked above. How do we know so much about unfamiliar aspects of reality? Put yourself in the place of an ancient astronomer thinking about the existential explanation of seasons. For the sake of simplicity, let us assume that you have also adopted the heliocentric theory. So you might be, say, Aristarchus of Samos, who gave the earliest known arguments for the heliocentric theory in the 3rd century BCE. Although you know that the Earth is a sphere, you possess no evidence about any location on Earth south of Ethiopia or north of the Shetland Islands. You do not know that there is an Atlantic or a Pacific Ocean. To you, the known world consists of Europe, North Africa, and parts of Asia, and the coastal waters nearby. Nevertheless, from the existential theory of seasons, you can make predictions about the weather in the literally unheard of places beyond your known world. Some of these predictions are mundane and could be mistaken for induction. You predict that due east or west. However far you travel, you will experience seasons at about the same time of year, though the timings of sunrise and sunset will gradually shift with longitude. But you will also make some counterintuitive predictions. If you travel only a little farther north than the Shetlands, you will reach a frozen region where each day and each night last 6 months. If you travel farther south than Ethiopia, you will first reach a place where there are no seasons, and then still farther south, you will reach a place where there are seasons, but they are perfectly out of phase with those everywhere in your known world. You have never traveled to more than a few hundred kilometers from your home islands in the Mediterranean. You have never experienced any seasons other than Mediterranean ones. You have never read nor heard tell of seasons that were out of phase with the ones you have experienced. But you know about them. What if you'd rather not know? You may not like these predictions. Your friends and colleagues may ridicule them. You may try to modify the explanation so that it will not make them, without spoiling its agreement with observations and with other ideas for which you have no good alternatives. You will fail. That is what a good explanation will do for you. It makes it harder for you to fool yourself. For instance, It may occur to you to modify your theory as follows. In the known world, the seasons happen at the times of year predicted by the existential theory. Everywhere else on Earth, they also happen at those times of year. This theory correctly predicts all evidence known to you, and it is just as testable as your real theory. But now, in order to deny what the existential theory predicts in the faraway places, you have had to deny what it says about reality everywhere. The modified theory is no longer an explanation of seasons, just a purported rule of thumb. So denying that the original explanation describes the true cause of seasons in the place about which you have no evidence has forced you to deny that it describes the true cause even on your home island. Suppose for the sake of argument that you've thought of the existential theory yourself. It is your conjecture, your own original creation, yet because it is a good explanation hard to vary, it is not yours to modify. It has an autonomous meaning and an autonomous domain of applicability. You cannot confine its predictions to a region of your choosing. Whether you like it or not, it makes predictions about places both known to you and unknown to you. Predictions that you have thought of and ones that you have not thought of. Tilted planets in similar orbits in other solar systems must have seasonal heating and cooling. Planets in the most distant galaxies. And planets that we shall never see because they were destroyed aeons ago, and also planets that have yet to form. The theory reaches out, as it were, from its finite or finite origins inside one brain that has been affected only by scraps or patchy evidence from a small part of one hemisphere of one planet. To infinity, this reach of explanations is another meaning of the beginning of infinity. It is the ability of some of them to solve problems beyond those that they were created to solve. The existential theory is an example. It was originally proposed to explain the changes in the sun's angles of elevation during each year. Combined with a little knowledge of heat and spinning bodies, it then explained seasons, and without any further modification, it also explained why seasons are out of phase in the two hemispheres, and why tropical regions do not have them, and why the summer sun shines at midnight in polar regions. Three phenomena of which its creators may well have been unaware. The reach of an explanation is not a principle of induction. It is not something that the creator of the explanation can use to obtain or justify it. It is not part of the creative process at all. We find out about it only after we have the explanation, sometimes long after. So it has nothing to do with extrapolation or induction or with deriving a theory in any other alleged way. It is exactly the other way around. The season that the explanation of seasons reaches far outside the experience of its creators is precisely that it does not have to be extrapolated. By its nature as an explanation, when its creators first thought of it, it already applied in our planet's outer hemisphere and throughout the solar systems and in other solar systems and at other times. Thus, the reach of an explanation is neither an additional assumption nor a detachable one. It is determined by the content of the explanation itself, The better an explanation is, the more rigidly its reach is determined, because the harder it is to vary an explanation. The harder it is, in particular, to construct a variant with a different reach, whether larger or smaller, there is still an explanation. We expect the law of gravity to be the same on Mars as on Earth because only one viable explanation of gravity is known: Einstein's general theory of relativity. And that is a universal theory, but we do not expect the map of Mars to resemble the map of Earth because our theories about how Earth looks, despite being excellent explanations, have no reach to the appearance of any other astronomical object. Always it is explanatory theories that tell us, which usually few, aspects of one situation can be extrapolated to others. It also makes sense to speak of the reach of non-explanatory forms of knowledge, rules of thumb, and also knowledge that is implicit in the genes for biological adaptations. So, as I said, my rule of thumb about cups and balls tricks has reached to a certain class of tricks, but I could not know what that class is without the explanation for why the rule works. Old ways of thought, which did not seek good explanations, permitted no process such as science for correcting errors and misconceptions. Improvements happened so rarely that most people never experienced one. Ideas were static for long periods, being bad explanations. Even the best of them typically had little reach and were therefore brittle and unreliable beyond and often within their traditional applications. When ideas did change, it was seldom for the better, and when it did happen to be for the better, that seldom increased their reach. The emergence of science, and more broadly what I am calling the Enlightenment, was the beginning of the end of such static and parochial systems of ideas. It initiated the present era in human history, unique for its sustained, rapid creation of knowledge, with ever increasing reach. Many have wondered how long this can continue. Is it inherently bounded, or is this the beginning of infinity? That is to say, do these methods have unlimited potential to create further knowledge? It may seem paradoxical to claim anything so grand, even if only potentially, on behalf of a project that has swept away all the ancient myths that used to assign human beings a special significance in the scheme of things. For if the power of the human faculties of reason and creativity, which have driven the Enlightenment, were indeed unlimited, would humans not have just such a significance? And yet, as I mentioned at the beginning of this chapter, gold can be created only by stars and by intelligent beings. If you find a nugget of gold anywhere in the universe, you can be sure that in its history there was either a supernova or an intelligent being with an explanation. And if you find an explanation anywhere in the universe, you know that there must have been an intelligent being. A supernova alone would not suffice. But so what? Gold is important to us, but in the cosmic scheme of things it has little significance. Explanations are important to us. We need them to survive. But is there anything significant in the cosmic scheme of things about explanation, that apparently puny physical process that happens inside brains? I shall address that question in chapter 3 after some reflections about appearance and reality. So this is the end of the first chapter, the reach of explanations. So here are some terminology used in this chapter. Explanations. So an explanation is a statement about what is there, what it does, and how and why. Reach, R-E-A-C-H, reach, is the ability of some explanations to solve problems beyond those that they were created to solve. Creativity is the capacity to create new explanations. Empiricism is the misconception that we derive all our knowledge from sensory experience. Theory laden is that when there is no such thing as raw experience, all our experience of the world comes through layers of conscious and unconscious interpretation. Inductivism is the misconception that scientific theories are obtained by generalizing or extrapolating repeated experiences, and that the more often a theory is confirmed by observation, the more likely it becomes. Induction is the non-existent process of obtaining, referred to above. Principle of induction is the idea that the future will resemble the past, combined with the misconception that this asserts anything about the future. Realism is the idea that the physical world exists in reality, and that knowledge of it can exist too. Relativism is the misconception that statements cannot be objectively true or false, but can be judged only relative to some cultural or other arbitrary standard. Instrumentalism is the misconception that science cannot describe reality, only predicts outcomes of observations. Justificationism is the misconception that knowledge can be genuine or reliable only if it is justified by some source of criterion. Fallibilism is the recognition that there are no authoritative sources of knowledge, nor any reliable means of justifying knowledge as true or probable. Background knowledge is the familiar and currently uncontroversial knowledge. Rule of thumb. So what is rule of thumb? Rule of thumb is the purely predictive theory whose explanatory content is all background knowledge. Problem. A problem exists when a conflict between ideas is experienced. Good or bad explanations. An explanation that is hard or easy to vary while still accounting for what it purports to account for. So a good explanation is hard to vary, whereas the bad explanation is easy to vary. The Enlightenment, the beginning of a way of pursuing knowledge with a tradition of criticism and seeking good explanations instead of reliance on authority. Mini-enlightenment. Mini-enlightenment is a short-lived tradition of criticism. Rationale. Attempting to solve problems by seeking good explanations, actively pursuing error correction by creating criticisms of both existing ideas and new proposals. The West, the political, moral, economic, and intellectual culture that has been growing around the Enlightenment values of science, reason, and freedom. Meanings of the beginning of infinity encountered in this chapter. The fact that some explanations have reach, the universal reach of some explanations. So here the reach means the ability of some explanations to solve problems. So the fact that some explanations have the ability to solve problems, or they have reached the universal reach of some explanations. The Enlightenment, a tradition of criticism, conjecture, the origin of all knowledge, the discovery of how to make progress, science, the scientific revolution, seeking good explanations, and the political principles of the West, fallibilism. Okay, so far page 21 to 32 has been read. Now what I'm going to do is I'm going to summarize the pages I have just read. So starting from page 21, and after summarizing each page and sharing and discussing what I can learn or what readers can learn, I'll summarize the entire chapter, the first chapter. This is also given at the end of the chapter. So here on the page 21, it discusses the limitations of myths as explanations for natural phenomena. It specifically focuses on the myths of Persephone and Freya, which both attempt to explain the cause of seasons. The author argues that these myths are fundamentally flawed because their details are easily replaceable without affecting their core explanations. This flexibility makes it impossible to distinguish between the myths based on their merits. So what we can learn from here is that the limitations of mythological explanations, myths often lack the specificity and testability required for scientific understanding. And the importance of evidence-based explanations is that relying on myths can hinder our understanding of the world, emphasizing the importance of scientific inquiry. The flexibility of mythological narratives. Myths can be easily adapted to fit new observations or beliefs, making them unreliable as explanations. And on the next page, it continues to the discussion of continues the discussion on the limitations of mythological explanations. It focuses on the concept of bad explanations, which are theories that can easily be adjusted to fit any outcome. The author argues that such explanations are unscientific, even if they make testable predictions. He emphasizes the importance of seeking good explanations that can be refuted by evidence, a key characteristic of scientific inquiry. What we can learn from here is that the importance of falsifiable theories, that scientific theories should be capable of being proven wrong, and the limitations of prediction alone. Making accurate predictions doesn't guarantee a theory's validity if it can't be tested and refuted. The role of evidence in scientific progress is that evidence is crucial for evaluating theories and advancing our understanding of the world. The distinction between science and other forms of knowledge is that the pursuit of good explanations is a fundamental characteristic of scientific inquiry that sets it apart from other approaches to knowledge. And in the next page continues the discussion on the Enlightenment and its impact on knowledge. It argues that the Enlightenment's emphasis on seeking good explanations led to the rejection of authority and the development of critical thinking. This shift in values. This shift in values and thinking patterns facilitated the rapid progress of knowledge and the emergence of the West as we know it today. what readers can learn is that the role of critical thinking in progress. So the rejection of authority and the adoption of critical thinking were essential for the advancements made during the Enlightenment. The connection between values and progress, the values of tolerance, openness, and the commitment to progress fostered by the Enlightenment contributed to the rapid development of knowledge. The historical significance of the Enlightenment is the Enlightenment marked a turning point in human history, shaping the values and institutions of Western civilization. Then the next page still continues the discussion on the existential theory as the explanation for seasons. It contrasts this theory with the mythological explanation of Persephone and Demeter. So here the author argues that the existential theory is superior because it is based on testable scientific principles and can explain a wider range of phenomena, including the phase difference in seasons between the hemispheres. So what readers can learn from here is that the importance of testability in scientific explanations. The existential theory is supported by empirical evidence and can be tested independently. The limitations of mythological explanations. The Persephone myth lacks scientific basis and cannot explain all aspects of seasonal changes. The predictive power of scientific theories is the existential theory accurately predicts the phase difference in seasons between hemispheres. And then the superiority of scientific explanations. Here the scientific explanations like the existential theory are more reliable and comprehensive than mythological ones. Then the next page still continues the discussion on the importance of good explanations in scientific inquiry. It argues that the value of a theory lies not only in its testability, but also in its explanatory power and simplicity. Bad explanations, regardless of their testability, are ultimately useless. The author emphasizes that good explanations are often elegant and can be improved through simplification, a principle known as Occam's razor. So, what we can learn from here is the importance of explanatory power. A good theory should provide a clear and concise explanation of the phenomenon it aims to explain. The role of simplicity in scientific explanations. Occam's razor suggests that simpler explanations are often preferable, as they tend to be more elegant and easier to understand. The limitations of testability alone. A theory can be testable, but still a bad explanation if it lacks explanatory power or is overly complex. The value of good explanations in science. Good explanations are essential for scientific progress as they guide research and provide a framework for understanding the world. Then the next page again continues the discussion on the nature of good explanations in science. It emphasizes that good explanations are constrained by existing knowledge and must be testable. The author argues that the pursuit of good explanation is a crucial component of scientific inquiry, as it helps to distinguish between genuine knowledge and mere fiction. So, what we can learn from here? The importance of constraints in scientific explanations. Good explanations are limited by existing knowledge and must be consistent with other established theories. The role of testability in scientific inquiry. Testability is a key criterion for evaluating the quality of scientific explanations. The distinction between knowledge and fiction. The pursuit of good explanations helps to separate scientific knowledge from mere speculation and falsehoods. The value of the quest for good explanations. The search for elegant and comprehensive explanations drives scientific progress and contributes to our understanding of the world. Next piece continues the discussion on the existential theory and its predictive power. It emphasizes that the theory can make accurate predictions about the weather in places that the author has never visited or even heard of. This demonstrates the theory's ability to explain a wide range of phenomena and its superiority over other explanations. What readers can learn: the predictive power of scientific theories. The existential theory can accurately predict the weather in regions that are unknown to the author, demonstrating its ability to explain a wide range of phenomena. The importance of testing theories. The theory's ability to make accurate predictions can be tested through observation and experimentation. The value of scientific explanations. Good explanations like the existential theory can provide valuable insights into the world and help us make accurate predictions. Then the next page continues the discussion on the existential theory and its reach. It argues that the theory's ability to explain a wide range of phenomena, including those that its creators were unaware of, is a testament to its power and effectiveness. The author emphasizes that the theory's reach is not a result of conscious effort or creative process, but rather an inherent property of the explanation itself. What readers can learn: the reach of scientific explanations. Good explanations can have a far-reaching impact, explaining phenomena that were not originally considered. The autonomy of explanations. The reach of an explanation is not something that its creator can control or manipulate. The power of scientific inquiry. The existential theory demonstrates the ability of scientific explanations to provide insights into the natural world that extend beyond our immediate experience. So the next page continues the discussion on the nature of good explanations and their reach. It reiterates that the reach of an explanation is determined by its content and not by any additional assumptions. The author compares the reach of explanations to the reach of knowledge in general, arguing that both are limited by their inherent properties. What readers can learn from this page is that the inherent reach of explanations. The reach of an explanation is determined by its content and cannot be changed through additional assumptions. The comparison between explanations and knowledge. Both explanation and knowledge have a limited reach, determined by their intrinsic properties. The importance of good explanations in scientific progress. The emergence of science and the Enlightenment marked a shift towards seeking good explanations, leading to rapid progress and increased knowledge. The next page continues the discussion on the significance of explanations in the grand scheme of things. It introduces the idea that the creation of gold and explanations are both limited to stars and intelligent beings, suggesting a parallel between these two processes. The author poses the question of whether explanations have any cosmic significance, a topic to be explored further in Chapter 3. What readers can learn: the parallel between gold and explanations. Both gold and explanations are products of stars and intelligent beings, suggesting a connection between them. The question of cosmic significance. The author raises the question of whether explanations have any inherent value or importance in the grand scheme of the universe, the importance of further exploration. The topic of explanations and their cosmic significance will be explored in more detail in chapter 3. So here, as you can see, that the word explanation is used too much, you can say, but this book is all about explanations. So here is the summary of this book provided by the author, probably. Appearances are deceptive, yet we have a great deal of knowledge about the vast and unfamiliar reality that causes them, and of the elegant universal laws that govern that reality. This knowledge consists of explanations, assertions about what is out there beyond the appearances and how it behaves. For most of the history of our species, we had almost no success in creating such knowledge. Where does it come from? Empiricism said that we derive it from sensory experience. This is false. The real source of our theory is in conjecture, and the real source of our knowledge is conjecture alternating with criticism. We create theories by rearranging, combining, altering, and adding to existing ideas with the intention of improving upon them. The role of experiment and observation is to choose between existing theories, not to be the source of new ones. We interpret experiences through explanatory theories, but true explanations are not obvious. Fallibilism entails not looking to authorities but instead acknowledging that we may always be mistaken and trying to correct errors. We do so by seeking good explanations that are hard to bury, in the sense that changing the details would ruin the explanation. This, not experimental testing, was the decisive factor in the scientific revolution and also in the unique, rapid, sustained progress in other fields that have participated in the Enlightenment. That was a rebellion against authority which, unlike most such rebellions, tried not to seek authoritative justifications for theories, but instead set up a tradition of criticism. Some of the resulting ideas have enormous reach. They explain more than what they were originally designed to. The reach of an explanation is an intrinsic attribute of it, not an assumption that we make about it, as empiricism and inductivism claim. Now I will say some more about appearance and reality, explanation and infinity. So this is the first chapter, the reach of an explanation. I will be soon back with the next chapter. So if you have a question to ask about the explanation and the arguments we have had in this chapter, please write your comment or opinion in the comment box. I'd love to hear your comment, read your comment, and discuss about it if possible.